These are notes on types of energy. Think of this as a brief overview, as we will go into these types of energy in more depth either within this unit or later on this year. But this will give you an idea of different types of energy and their different characteristics. We're going to talk about what energy is exactly later on this week. One thing you should know is that there's some discussion as to whether there are only two types of energy, that being kinetic and potential, and that every other subtype is a type of kinetic or potential. And then some things you'll read will say that there's lots of different types of energy. I don't think it matters necessarily how you categorize them, as long as it makes sense to you and you understand the different characteristics of these types. So we'll start though with potential. Potential energy, or PE, is stored energy. It's energy that can be used to do stuff. And there's several different types. You have gravitational potential energy that has to do with the distance above a surface that an object is resting, or even is moving, but the distance above a surface. There's chemical potential energy, which is the energy that has the potential to be released through a chemical reaction. And there's elastic potential energy, which is potential energy from stretching an object, such as a rubber band. I'm going to give you the equation for gravitational potential energy. That's the only equation for potential energy we're going to worry about in this class. And that for GPE, or gravitational potential energy, is mass times gravity times height, or mgh. You'll hear that a lot. Or, noticing that mass times gravity is weight, you can also say it's weight times height. So then obviously the next type of energy is kinetic energy, which is known as Ke, and that's energy of motion, or 1/2 times mass times velocity squared, or 1/2 mv squared. One thing to note as far as the math of kinetic energy goes, the velocity is the only thing that's squared. You don't square the whole thing. So I tend to calculate this backwards, where I'll square the velocity first, then multiply the mass, then either divide by 2 or multiply by 0.5. Thermal energy is the total potential and kinetic energy of a system. So you'll often see TE equals PE plus KE. It also can be thought of that as the energy that arises from how the molecules in a system are moving. So there's always some thermal energy because there's always some molecular movement. Even in solids, I think you learned that last year, that even in solids the molecules are moving slightly. The next one we're going to look at is electromagnetic energy. We call this EM, generally EM radiation or EM waves, but it can be thought of as electromagnetic energy, and that's energy in the form of waves of different wavelengths. So different electromagnetic energy has different size waves, and we'll talk about properties of waves later. And these waves can travel through space, and so energy that travels through space is called radiation. This doesn't make them radioactive. That's just our word for energy transfer through space. So light waves, for example, are a type of EM radiation. Next we have chemical energy. That's energy released through a chemical reaction. And finally we have nuclear energy, which is energy released through combining the nucleus of atoms, and that's called fusion when you combine them, or energy released from splitting the nucleus of atoms. And nuclei in the notes is the plural of nucleus. So if you're splitting nuclei of atoms, that's called fission. This is not an exhaustive list. There's more. We could talk about sound. Sound is a type of energy. But these are kind of 6 that we're going to look at in this year.